Hello everyone and welcome to my video. It is a Java crash course for JavaScript programmers. I come from a JavaScript background and I've recently learnt Java for my work, and I want to share with you the basics of what I learned and how it relates to JavaScript. So if you're looking to dip your toes into the world of Java and just kind of see what it's all about, maybe you're still trying to decide if you want to learn it, then this gives you a little taste tester and a starting off point from which you can begin your Java journey. So with that being said, let's get into it. Just a reminder to please like, comment, and subscribe. Comments in particular are really welcome. I never know if I do a good job or a bad job unless you comment. So please do let me know what you think. And if you found it useful, I would really appreciate, your support. Thanks so much. Let's get started. All right, let's start by talking about project setup. Now, as you know, with JavaScript, really all you have to do is create a new JavaScript file and then you start typing and really you're ready to go. With Java, it's a little bit different. What you need to do is once you open IntelliJ, which is the program that I would advise using as your IDE, I would go up to File, New, Project. Then you have to ensure that you have the correct version of Java that you want to use in there. You can just Google install Java for your operating system and I'm sure you'll find plenty of resources for doing that. Then you hit next and then next again. You can use a template if you have one, but I don't. And then you simply name it whatever you want, whatever. Yeah. And then you hit finish. Then it will say, oh, do you want to open it in a new window or this window? Since I already have a window open, I'll say new window in this case, but I'm going to just close that again because I've already got a project set up here. What this does, I've named this project crash course. It creates a little folder that has some basics in it. And what we want to do is work within this folder, within the source folder. We're going to right click and do new class, new Java class. And then here we can just type the name of whatever class we want to create. Let's just say person. It's the easiest one. And we'll come back to that later. But for now, we're going to work in main class. And what you will find as we go through here, because as you can see, this is the kind of basic structure of what I'm going to be covering with you in this video. What you'll find is that most of this stuff actually doesn't happen out here in the automatically created class, but actually happens in what's called a main function. And we'll look at that later. But for now, let's start with the basics. Let's start with variables. Now, as you know, in JavaScript, variables are declared with either let, first name equal, Anna, or you could use var first name, blah, 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 blah. Or if it's a constant, you would use const. Yeah. And this doesn't really tell us a lot of information. And if you just declare it with let's say you don't even specify what's in there, you don't really know what's going to be within this variable. I mean, it says first name, but for all we know, we could put a number in there. We don't know. So what we actually put in there determines what type it is. Similarly, we can redeclare something. I could say then after doing that, so I've already declared it, I could call it, 42. And JavaScript has no problem with this. It just says, oh, okay, you were a string before, now you're a number, that's cool, whatever. No big deal. Java is a little bit stricter, and this is the huge difference that will kind of dawn on you the more Java you do, the more you'll discover that type becomes everything. So just as a bit of an example of what declaring a variable in Java looks like, we can actually say, for example, string first name equals Anna, semicolon. Okay, so what's going on? Firstly, Java kind of already knows that this is a new thing, right? Because we haven't mentioned it anywhere else. We won't have any compile problems. What we do is we actually just specify what type it is before the variable name, and then we can give it a definition if we want one. Again, we don't actually need that there. We could just do string first name. But the really important takeaway here is that you absolutely must declare the type of the variable when you declare it. I mean, that's how you do it. I can't type, for example, string first name equals 42. As you can see, I get the red line of doom, and it says provided int, that means integer, and it says, you know, change the field first name type to integer, and it kind of gives me some hints as to what I need to change there, but it simply will not let me do it. And this also can't be changed then further down the line without me explicitly stating that I want to change it. So that's the really important first step when it comes to declaring variables. You must indicate what type it is. So this, of course, begs the question, what types are there? And we're going to start, there are two types, basically. There are general categories of types: primitive types and non-primitive types. Yeah, that makes sense. So I'm not going to go through every single type. This is a crash course, so I'm just going to give you a brief rundown of what exists that you're most likely to use. The first is a car. Yeah, so car, a letter. And this is just a single Unicode character, like this. Yeah, A. And this goes in single quotes. Yeah, single quotes. A single character in single quotes. Yeah, pretty simple. Next we've got a Boolean. This should be pretty familiar to you by now. So Boolean is logged in, classic, is false, right? Again, pretty straightforward. We then have three types of numbers, but I would say on the whole, you're mostly going to use two types of numbers. The first is int, which means integer, a whole num. Let's just stick with 42. And we've got a double, and a double is like a long float. Yeah, you know floats from JavaScript, but double tends to be the default and tends to be the most used. The float also exists, but as I said, crash course, let's stick with it. So double, a decimal point num equals 42.4242. Now, the one thing I just want to have a quick note in here that you've noticed I'm always putting these semicolons at the end. Unlike in JavaScript, these semicolons are essential. You can't not use them. They are not optional. So you will probably see me forget a few times, just old habit from JavaScript left over. But this is something really important to remember. Okay. Next we have non-primitive types. Let's talk about those. Now, non-primitive types are also known as object types, and these are denoted with a capital letter. So you noticed up here on line 8 that I used a capital letter S for string. That indicates that it is an object type or a non-primitive type. So of course, string and new name is Bob, right? And then we've got a few here that are, I suppose, non-primitive or object versions of the primitive types. Now, I'm not going to bore you with a long explanation of how and why this has come about, but all you need to know is that sometimes you will need to use the object version, but wherever possible, you should try to stick to primitive types. But this will happen quite a lot, that you will need to use double, a new num will equal 54.56. You will have integer, a new whole num equals 90. And you will have Boolean is logged out, I guess, equals true. So these are basically the non-primitive types. It's important, I suppose, to know the difference because, as I said, there are some structures that will require you to use non-primitive types. But for the most part, I would say it's not super important when to use one versus the other in just general life. As said, just try to default to the primitive types if you can, and then non-primitive types when you have to, would be my general guideline. I will add quickly that you can change between types if you need to change a string to an integer or a double to an integer to a double, or anything along those lines. Of course, there are ways to do that. The one way is by kind of putting it in brackets beforehand. So for example, if I want to convert a new whole num into a double, I can actually say double another num equals, and then kind of put in brackets here, double a new whole num, like this. And this is kind of a way of telling Java, I know that this is not the correct type. This is not a double. Yeah, I've said here I want a double. I've given you something that is not a double, so I need you to change it into one, please. And of course, this kind of thing is very useful when taking user input, which tends to come in as a string, and then converting it. So that's one of the many ways to do that. But as I said, this is a crash course, so I'm not going to go into too much detail on this, but that is something that I would be looking into after this as a next step, how to convert between different data types. Okay, let's talk about privacy. This is something that was very new to me when I came into Java, and that took me a little while to get my head around. But the basic idea is that in Java, you can indicate for each variable or function, and they will usually call functions methods. So if I use the term method, please just understand that I am using the two terms interchangeably. So for anything that you declare inside a class, and Java is object-oriented, so it does tend to work with a lot of different classes, you will be indicating what privacy or lack thereof the variables and functions or methods have. And what this means is where you can access them, right? Can you only access them from within that class? Can you access them from outside that class? It basically has to do with scope. And if you think of this in terms of scope, it will make your life a lot easier. So let's talk about privacy. The most obvious one is public. Public basically indicates that you can access this variable from outside the class within an instance of it. So we'll get to what that means a bit more down here where it says class as an instance, right? But for now, let's talk about this, and then I think it'll make a lot of sense. So public, let's say public last name, because we've already done first name. And I should, of course, indicate the type. Old habits die hard. Public string last name equals McDougall, right? So here we go. There's our semicolon. There's our spell checker underlining, because McDougall is a word that it does not recognize. And we have a public last name there. So if we were to put this actually inside our person class, whenever we create a new person, the default last name would be McDougall, and we would access that person by doing like person.last name, right? And we could actually access that. But if we put private string middle name, not a big secret, but my middle name is Jean, then we wouldn't be able to access this property even when we create a new person, even if the middle name is Jean. That information would only be accessible within the class and within the functions in that class. So this is very, very similar to JavaScript. So if you're familiar with the use of classes in JavaScript, this will not be foreign to you, this idea, but it's basically, again, to do with scope, that you cannot and should not access any information from outside the class that isn't essential, right? You should mostly be trying to work with it inside the class and keep everything encapsulated as best you can. So that's the basic difference between public and private. There are other types of privacy. Again, this is a crash course. If you want more information on that, I do recommend going and looking it up. There are other ways that you can control where this information is accessible from and how you can use it and all this kind of stuff. So, but most of the time you'll be working either with public or private, so it's most important to understand those two. Then we can have a look at the word final. Now, I mentioned earlier, right, if we scroll right up, I mentioned earlier that in JavaScript, we use let, var, or const to declare variables / constants. And I spoke a little bit here about variables, but I didn't mention constants. So maybe you're thinking, hang on, how do you actually create a constant? Well, there's no constant keyword in Java, but there is final. And final basically says, as soon as this is declared or as soon as this is initialized, don't change it. Right? So you might say private final string date of birth equals, I don't know, the 1st of January 1981, right? And then you've got this date of birth string, and you can't change that. It's a piece of information that is never going to change, right? So that's how you make it a constant, is with this keyword final. It's important to note here that if you do this, you have to initialize it when you declare it, right? You can't like initialize it and then come back and change it again later. It's, or initialize it later, I suppose you should say. It's done. This is it. One line. It also doesn't have to be private. It can be public. Yeah, public final string first pet's name equals, I don't know, Sally. Yeah, so the name of your first pet, it never changes, right? Your first pet's your first pet. But maybe you want this information to be public. Maybe you want to be using it elsewhere in your program. So you make it public, but you say final so that it's clear to the program that it's not changing. So that's really all there is to it. So let's move on. Let's talk function declarations. Now, as you know, in JavaScript, it's really very easy. Function, myfunc, blah, 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 blah. Yeah, does stuff. Awesome. It's not quite so simple in Java. Unfortunately, there's a little bit more that we have to tell the program before we begin. So the first thing we have to tell it is whether it is private or public. So this is a method of functions, pure functions in the way we use them in JavaScript. I mean, they don't really exist in Java. Everything is tied to a class. And what you'll find is that the temptation is to kind of just put everything into one class and program it like you would JavaScript. And you have to kind of, I guess, fight against that, that propensity. So what you have to do is, with every function, you need to do similar things to what we did for our variables and our constants. The first thing is to indicate what privacy it has. So let's go with public, right? Let's say this is a method that we want to be able to access easily. You might already be familiar with getters and setters from JavaScript, so let's stick to that. But we also need to indicate here what it's returning. This is different to JavaScript, right? In JavaScript, you kind of write a function, and then at some point you either return something or it has a side effect, and you don't really need to say in advance what any of that is. You don't need to indicate how this function is going to be used. You don't have to indicate what this function is returning. You just write a function and then you just use it however you want, which is awesome and very flexible. Java kind of holds you to, like, it kind of makes you promise what you're going to do and then stick to it. So let's say that I am going to return a string. Yeah. And so I've got the privacy, in this case, public. We'll talk later about what static is, but if we were to put something like static, we would put it in there. And then we've got string, what we're returning. And then we put the name of the function, get full name, right? And then we have our function body, just like in JavaScript. And you can see here, it says here missing return statement. So the IDE is actually holding us to our promise. It's saying, you told me you're going to return a string, but you haven't returned anything. What's the deal? So we have to keep our promise, right? So we could say then return first name plus middle name plus last name, right? Pretty simple concatenation, just like in JavaScript. So from here to here, it looks the same as JavaScript, but this bit here is what makes it different. Yeah. Privacy, what we're returning, and then we have to return that thing. If we tried returning 42 here, womp womp, does not like it, right? Because it's saying wrong type. It's saying you've provided an integer and you told me you're going to return a string, right? So we have to keep our promise. So these can be private, so you can return any type here at all, right? So there's no restriction on what you return as long as you keep your promise in the end. So that's function declarations. Okay, let's talk about void. Okay, void is our other option. So you saw here I said, okay, you have to indicate what you're returning. But what if you don't have anything to return? What if you just want to print something to the console, or you just want to, I don't know, you just want to change some data in your database. You don't actually want to return anything. Well, that's fine. You can do that. And you do that with the word void. Yeah, void takes the place of the data type, and you're basically telling the program, I want this method to do some stuff, but I don't want to return anything at the end of it. Just let me just do what I want to do, please. And hopefully it lets you. So let's say private calculate insurance premium. All right. Now you can see here it's not happy with me yet because it says return type required. And I'm like, look, I want to calculate this insurance premium, but I just want to update it in the database, right? So in fact, let's just even change it to update DB insurance premium. Yeah, just to be clear. So you don't actually want to bring this number out or do anything with this number. Like you've already got the number, let's say, and you want to do some stuff with it. You just put void, right? Now, let's say we want to take in the new insurance premium that we've calculated somewhere else, right? This function or method is just to update the database. So we've already calculated the insurance premium elsewhere, and we want to bring the information in. So in JavaScript, if you have a parameter like this, you would just say new premium, right? Okay, why is this red? Well, because we don't know what type it is. Yay! So in order to tell this what is going to come in, we need to indicate that. So let's say double, new premium. And now you can see it's very happy. It says, oh, you're talking about a parameter. Great, okay, and the parameter is going to be a double. It's going to be, you know, a string, a floating string. It's going to be a float, as we would say in JavaScript. So we can then use this information and we can say, you know, we run some db.update and then new premium, right? Like that. And let's say this exists, right? And, or like, I don't know. Well, you know, it doesn't have to work because this isn't a real thing. So I don't know why I'm pulling myself over the coals for this. All right, so this is basically it for void, right? We have a side effect we want to do. We don't want to return anything, and we want to take a parameter. And whenever we want to take a parameter in a Java function, we also have to indicate what type that parameter will be. All right, so now that we've covered that, let's have a little look at what the main function is, because most of the time when you're actually running stuff inside your program, you're going to run it from your main function. So it's important that we know what this is. Now, this is a fun little shortcut, which is Control J. And if you do this, there are a bunch of kind of cool shortcuts that you can add. And one of them is main. So you can either click that or you can just type main. So I'll show you the other way as well. That was just clicking, and then you can also do Control J main, yeah, like that, and then it will create a main function for you. So this is kind of like the default main function. You really probably should not mess with this. As you can see, it's public, static. I'll talk about that in a sec. Void, i.e. it's not returning anything, and then it takes here arguments, right? It's called args, and this is how you indicate that they're an array of arguments. It's not really important that you understand how this works. Just trust me that this is the main function you'll be running. And you can tell that it's something you can run because this little green arrow appears here, right? And it tells you, okay, you can do some stuff now. Like, this is how you can run this program. But otherwise up here, you know, even when we had here a function, you see there's no green arrow. Like, we can't do anything with it. So you will be running the program from within your main function or main method. So here's your main method. This is where the magic happens. And we can talk more about what actually happens in there later, but let's just keep going for now because we've still got a lot to get through. As I mentioned earlier, Java is an object-oriented programming language, unlike JavaScript, which is functional in nature. So what this means is that we are trying to encapsulate our data and our structures that we use in our programming into classes. And then we call on those classes and we create instance of that class. What does this look like in a practical sense? Again, this is very similar to JavaScript classes. So if you're familiar with those, this bit might be a bit boring. You might want to skip over it. But the general gist of it is this. Let's say we have a database of people for whatever reason, and we want each person to have some things about themselves that we use over and over again, right? So we would have public first name, public last name. Maybe we don't want people to be able to access their middle name for whatever reason. I don't know. Maybe we have a user ID or something like that. Right? And of course, being a JavaScript programmer, I have forgotten to indicate what types they are. So let's go through and do that. Right? Well, string, and let's make this an integer. Yeah, because it's just going to be a number. All right, so then we have some things about the person that we want. And then let's say we want to create a public method. And we'll just stick to the same one we had before. Get full name. And then we will return first name plus middle name plus last name. Right, okay. And, you know, for the sake of everything, let's just make this public for now because it's going to be easier for demonstration purposes. All right, so then here we have this information. Now this is, I want to say before I do all of this, this is not the proper quote unquote way to do it. You should be using setters or constructors to do this. We'll talk about constructors in a second, but basically the gist of it is this. If the person, we create the person first. So we would say, we actually will do it up here in main. We'll say person, new person equals new person. And in fact, you know what? I'm going to change that because I remember finding this very confusing when people used this kind of terminology. Let's just say Bob Ross. Okay. So person here is the type. Remember I said that every time you declare a variable, you need to give it a type. Well, here's the thing. A class is considered a type. It's a complex type, right? It's an object type in a way. And what we are doing here is we are saying Bob Ross is going to be a person type. He's not a string, right? He's not a double or an integer or a Boolean. So of course, but he still needs to be something, right? So we give him the person class. And then we initialize, or we instantiate, there we go, a new person in order to say, here he is, I want this new person, and Bob Ross now has this structure kind of built into him. And then we can say Bob Ross dot first name equals Bob, right? And Bob Ross dot last name equals Ross. I have no idea what Bob Ross's middle name is, but let's just make it up. Middle name equals, I don't know, Julian. I always liked the name Julian. Okay, so there we go. So he's now Bob Julian Ross, lovely name. And there he is. You know, we've now done this. And now if we wanted to get his full name, we could actually just do Bob Ross dot get full name, right? And you can see as well, if I just go back a bit, when you start typing, I type G, and straight away, IntelliJ is saying, oh, you probably want to use this method that you've defined in the person class. So it's really useful, and you should really look at what it suggests to you because it will save you a lot of typing. So this is kind of the general idea, right? You can't just call get full name without creating first a person. It's tied to this person. It's reliant on this person's information. And we can see that here. It makes sense, right? If we don't already have a person, then none of this information will make sense. But this is still true even if we have something that doesn't rely on that information. So we might have public string say hi, right? And then that returns hi, right? Now this is not reliant in any way, shape or form on the information we have in the person class, but as far as Java is concerned, it doesn't care. We still can't say person.say hi. You see, it doesn't suggest it to me. It thinks there's a problem. It's saying, yo, look, and there it says non-static method, say hi, cannot be referenced from a static context. It's like, this is not a thing. You have to create a person. Whereas if we had bobross.say hi, it's happy because we already have an instant of that person. So this is a huge difference between JavaScript and Java, and it's the thing that I've had to get the most used to. But actually, you know what? While we're here, I'm actually just going to move this section up because it makes sense to talk about it now since we've already mentioned static methods. Sometimes you want to be able to call a method like this from anywhere, right? Like, I mean, you don't want to have to always create a new person just to say hi, right? So how can we make it say person.say hi? How can we get that to work? Well, it's simple, really. We just put here public static. Yeah, and you can see now it's happy. The little red line has gone away. And here this has gone into italics and it's saying, great, this will work, right? So suddenly this makes sense. So static basically means let this method be accessible from anywhere within the scope of what I've indicated. In this case, public means publicly available, so in all the classes. You can call this method without having to create a new person. So we could delete all of that. We won't, but we could. Hang on, let's see if I can remember this shortcut. Oh yeah, she's good. And now this will still work. It doesn't rely on it being instantiated at all. So that's awesome. And that's static. And so I guess the temptation as a JavaScript developer would be to use static on everything. And that's basically what I did when I started learning Java. I was like, whoa, what's going on? I can't access my function. I'm going to just use static everywhere. And I want you to resist. I want you to resist that temptation as much as you can. It will be necessary sometimes, but most of the time you will probably want to keep things within their classes and their instances. Okay, so let's talk about constructors. Again, quite similar to JavaScript classes if you're familiar with them, but we'll go over it anyway because they're pretty important. Now this is really laborious, right? We don't want to have to constantly do this. Bob Ross first name, Bob Ross. Like what if we have 100 people? We have to do this over and over again. It's a pain in the ass. So let's not do that. Let's make it much easier on ourselves and create a constructor. All right, let's go into our person, right? And here, now again, this cool like things you can do. If you do, I think, oh gosh, Alt insert. There we go. Alt insert. It's fine because if I'd gotten it wrong, I could have just edited it out, no problem. We just hit enter here for constructor. So we've got getters, setters, equals, hash codes. These are all things that you will discover as you get deeper into Java. But for now, let's just stick to constructors. And we're going to talk about ToString as well. But the rest I'm going to leave for you to investigate further in your travels. Constructor. All right. And here we can choose what we actually want to construct with. So let's say we want those three. Okay. There we go. So very basic constructor. Here it says public person, and then you can enter the first name, last name, middle name, right? So now here, rather than all this, you see now I've got a little squiggly underline because it's like, dude, that's not what you said you wanted to do. You said you wanted a first name, a last name, and a middle name. All right. And here we can also hit, I think it's Alt P. Is it Alt P? It's not Alt P. Is it Control P? It is Control P. Here, if you hit Control P, it will show you what the parameters are that you want to enter. So here we can see it very easily. Bob, oops, and Ross. Why did that? I'm sure I put a capital letter there. Bob, Ross, and then it says, okay, now I want the middle name, and we'll put in our made up middle name, which is Julian. So you enter these just like you enter arguments in a JavaScript function, except Java kind of does a lot of the work for you and tells you what you need to put in there. And then you can see this IntelliJ shows you here what parameters you've entered. So you can kind of check that you've gotten the right one. So it's just a nice little feature that you can have. And now this works, right? Because there are no little red lines there. Because now when you do this, it will take those 3 parameters or 3 arguments that you've entered and apply them to the person. And then if you wanted to do get full name, that would work. If you wanted to do bobross.firstname, that would also still work. Apparently not. Not a statement. Yes, that is true because I haven't done anything with it. So you could say Bob's first equals. Yeah, oh, and of course, you need to specify the type. And here you will see the general struggles that JavaScript developers will continue to hit with Java. So I feel like this is a really good demonstration. I never said I was an expert. So you can kind of see here how that works and what the errors are. So that's kind of like the basics of that. Let's talk about ToString. A ToString is a really great thing that you can change. And as far as I know, and please feel free to correct me in comments, as far as I know, this does not exist in JavaScript as an option to override. But I mean, maybe it does and I've just never discovered it, but I don't know of it. So again, let's do Alt Insert. Here we go. And we've got here ToString. Let's enter. And again, it's going to give us some options here. I'll show you what it does, right? Okay, if you do that and you select the default, it will return a string that kind of just concatenates all the different, I suppose, variables or properties that you're using for that person. That's fine, but we can actually make this even more personal, I suppose, and we could say, this person's name, oops, double. This person's name is first name, this dot first name, plus this dot last name. Oh, we need a space. Yeah, like that. That'll do, right? We don't need much more than that. I think that kind of does it. And so what does this do, right? I'm sure I can hear you being like, okay, that's nice. I know how to return a string, but why are you showing me this? And why does it say override? Well, each class kind of has a default ToString. And whenever you put that into, for example, a console log that we'll get to soon, it will automatically use that string version of the class, right? So if I do here now, bobross.ToString, right? This will actually show me this person's name is Bob Ross, right? Rather than showing me like an object identifier or like the hash code or something like that, it will actually show me the information that I want to get when this is used in a string context. So that kind of helps us to create user-friendly responses. So for example, oops, here we go. We can just do Bob Ross like this, and this will actually show us this person's name is Bob Ross. It will show us the string version here. It will default to showing us that, which is really cool. And if we want to check that, here I've just made the window a bit smaller so you can see. You go run main. Again, like I said, this little green arrow shows us what's what. We hit that, and there you can see this person's name is Bob Ross. So even though we've just entered Bob Ross, we haven't entered bobross.toString or anything like that. We actually get the string version there as the default. So that's a really cool thing that Java has, where you can kind of change that, and you'll see that a lot of times that is one of the things that people change earliest when they're creating new classes, is to create a string version that is a bit more palatable. And I suppose you want to see what happens if we don't have that. I would. So let's comment that out. Am I going to get this right? I am. Aha. Okay, and then we'll try again. Great. So we get the class, and then I am assuming that's the hash code for its location in memory, which is not particularly useful to us. And that's why you override the ToString method. Okay, so we're going to move on to arrays and array lists. Now, if you come from JavaScript like me, then you hear the word arrays and you're like, hell yeah, I got this. I know arrays, but I've got some bad news for you. Java arrays are a bit different. And actually, array lists are probably closer to what you're used to working with in some ways, and in other ways not, which I know is not very helpful right now, but you'll see why soon. So let's start with arrays. I'm actually going to put it up here in the main section instead. So let me just actually copy paste it up here. So the first thing about arrays is that we have to say what data type we're actually going to store inside the array. So if we do string, right, and then we'll say names equals. Now, this string tells us what type of data is going to be stored inside the array. And then these square brackets say this is going to be an array. Yeah, this isn't just a normal string, right? This is going to be an array of strings. And then here, rather than using the square brackets like in JavaScript, we use the parentheses or the curly brackets. And we can, in here, state what our names are. Yeah, like Anna, Bob, oops, it might help if I did that. Sandy D, Alex, and of course our semicolon. So we have that. Now here's the kicker. We cannot now change the length of that array. So if we want to change an item inside that array, we can still do that, right? Let's say we want to change Sandy D, oh, come back, to John. Right, that's fine. It'll let us do that, no problems. But if we want to add an item to this list, we can't. There's no push method, for example, here. There's no just adding something on, you know, we can't just say names 12 equals Popeye. You know, it's like, what? What are you doing? Right? And if we try to then log this, you'll see what I mean. Right. I'll try running this. And I don't know if you can see this. It says index 12 out of bounds for length 4. Right? So it's saying, what? When you declared this array, you said there were only 4 items, and now you're trying to put something in at 0.12? What? That doesn't make any sense. Super confused, and it's not happy with it, right? So that's a huge difference, I suppose. That's one thing. All right, the other way we can do this, let's do numbers this time. So let's do an array of integers, and they'll be ages. Let's say the other way we can declare it is do it this way. We can do a new int, and then do square brackets, and then we can allocate how much memory we want this array to take up. And in other words, how many items we want this array to have. So we could also then go 20, right? And this is kind of a way of cheating the limit. Like you could make this 2000 or something and try to make it so out of bounds of how many people you're going to use or numbers you're going to use in this case that it wouldn't be a problem. But of course, that's not really a very efficient way of doing things. And then what happens if your program does expand? What happens if it takes off and then you need to put more ages in and more names or whatever it is? Then you're kind of stuck. And then of course, it's just like with any other array, you can just pop things into any of those 20 places, as I showed you here on line 79. So that's arrays. Now let's have a look at array lists. So array lists are much closer to what we're used to working with. And I'll show you why. With array lists, we also have to indicate what data type we're going to be storing. As far as I'm aware, you cannot mix and match data types. You can't have like Anna 42 true, anything like that won't work. But you can add and remove items, move them around a bit more. It's a lot more flexible, and this is how you declare it. Array list, and then the data type, like that. So it's a little bit different. Here you can see we do string and then the square brackets to indicate the array. Here we actually say, no, we want an array list with strings, and then we'll call it, yeah, why not, students equals. And then we'll go here with new, we'll use the new keyword, array list. Okay, here we go. So now we have an array list called students, and we can do whatever we really want with this. But it is a little bit different. Rather than using bracket notation, we use get and add. These are two methods that exist on this. So we can do students.add. Oh gosh, here we go again. Harriet, lovely name. Students.add Francois. I'm getting a bit French in here. Yeah, students.add Lauren, you know, etc. And then if we want to pull something out, well, this preserves the order that we've put them in, just like an array would in JavaScript. But what we can do here is do students. What we can do here is type students.get, and then we put in the number we want, right? So we actually then put in 1, right? And what it will happen if we log this, students.get 1, is we should see Francois. That is one thing that is the same, that indexes or indices, I was halfway between the two words there, indices in Java are exactly the same as indices in JavaScript in that they start at 0. Yeah, they are 0 indexed. So if we run this, oops, there it is. Run. Then we'll see Francois, which is exactly what we expected, which is lovely. So that's array lists. Yeah, you use add and get to play with those. The other thing that's important here, and actually I was going to talk about this later, but we might as well talk about it now, is that when you're working with array lists, you actually use size instead of length. So a lot of methods in Java are the same as in JavaScript. I would say of the methods, the standard methods that you use in JavaScript, probably like 60 to 70% of them are the same or extremely similar in Java, but there are some differences. With strings, .length still works exactly the same way. We had earlier, we had Bob Ross ToString, so you could do Bob Ross .ToString .length like that, and that would work. Oops, there we go. Now you can see Bob Ross .ToString .length, and that will work because it's a string. But if we did students .length, you can see we're going to get an error. It doesn't like it. So here we actually have to use size. So when you're using collections, you use size, and when you're referencing strings, that's when you use length. That's a nice little difference between JavaScript and Java. So those are the basics of array and array lists. Of course, there are lots and lots of methods you can learn for array lists as well, just like in JavaScript. So I'm going to leave you to sort that out, and I'm going to move on to Hashmaps. Okay, let's talk about Hashmaps. Hashmaps are the Java equivalent of objects in JavaScript, yeah? JavaScript objects, right? Now in JavaScript, we would do something like let person, let's just put it this way, equal, and we'd have name, and age 33 or 33, like that, and so on and so forth. In Java, you guessed it, things are a little stricter, and we have to follow a few more rules. Also, if we were accessing things, that's also different, but we'll get to that in a second. In JavaScript, you begin with this keyword hashmap, and you can see here, even when you do this, it kind of gives you a bit of a guideline as to how this is done. This K stands for key, and the V stands for value. So we have a key-value pair, just like we do in JavaScript. Yeah, so we can do that here. Except what we put in these, this tag, I suppose you'd call it, is we put the types that we're working with. So let's do string and int, right? And now I'm about to show you something as well that kind of goes back to what we were mentioning earlier, but bear with me for a second. And then we can do student ages like this, equals new hashmap string int. Yeah, it kind of auto-completes a bit for you there, which is very helpful. But you can see we've got this red underline. Now, earlier I mentioned the types. Yeah, I said, oh, you know, sometimes you have to use an object type, but you should try to default to the primitive types. Well, here is a great example of that. When you're using a hash map, the collection has to use objects. And since primitive types are not considered objects in Java, we do have to convert this into the object or the non-primitive version, which is integer with a capital I, like that. Now you can see here that we are a little bit restricted because we have to use integers, right, as our second thing. So I can't actually do name Anna in this upcoming example I'm going to give you because the second item, the value, has to be an integer, right? The key will be a string and the value will be an integer, and I'm restricted in that way. And that's why I've called this hashmap student ages, because what we're going to do is put the student name and then their age, right? So how do we actually put a new student age into this? Well, we do student ages dot put. Makes sense, yeah? So it's not dot add like we had earlier. Yeah, we had add and get for array lists. Here we've got dot put, and here we will put the new student. We'll call him Fred. Why not? And then we will put his age, and let's say he's 42. Why not? He's like me, starting late. And so we've got Fred in there now. And we'll put me in there as well, just so that, you know, we've got more than one person in there. Anna, 33. And then what we're going to do here is we are going to pull him back out again. So how do we get him out? Well, we do student ages dot, you guessed it, get. Except this time, you can see again, IntelliJ is helping us here. So really, this is part of the reason I encourage you to use IntelliJ and keep an eye on what pops up. It tells you here, you have to put the object key to get that. So we would put in here Fred, like that. And that would pull that item out of the hash map for us to use however we feel we want to, right? And that would give us his grade. Yeah, so we could even say here, oh, his age. Yeah, so we would say int Fred's grade equals student.ages.get Fred. And this is, I think, if I'm not mistaken, automatically converting it into an int for us. But I think we could also put integer here like this, and it wouldn't make any difference. But I like, as I said, sticking to primitives as much as I can. So there it is. And that's how we pull Fred's grade out then of this hash map. So you might be then thinking, well, hang on, how do I do something like this? If I do want to mix this stuff up and I want like different types and different pieces of information, well, again, this goes back to Java as a language. You're encouraged then to use a class like person and to have different fields for that person. And you could make them all private if you want, you know, if you just want to work in there. But this kind of gives you an idea of the difference between how you have to think in JavaScript versus how you have to think in Java. Where for me anyway, I kind of defaulted to objects and object types in JavaScript. Here, you, I guess, default to classes. But it is important to note that you can make a hash map that has classes within it, or like instances of a class within it. So for example, we could do hashmap ID might be an integer. Yes, we'll do integer for an ID number, and then we'll have person. Ooh, all getting interesting now, isn't it? Student, let's call it student list or student attendance or something. I don't know. Okay, we'll just work with this. We'll work with this, it's fine. And here we'll again say integer and person. Yeah, just reiterating it. Again, you will find a lot of the time when you move over to Java, you'll be just indicating what types you're working with a lot more. Okay, so now we have the student attendance, and what we can actually do here is do student attendance dot put, and we could say ID 1, let's say, because that's our key here, is our ID number for this person. Or we could make it more interesting. 19204. And then here we can put Bob Ross, who we created earlier. Yeah, because he's a person. And now we can start kind of building up a collection of people or students or whoever we're creating with our little system here. So that's how Hashmaps work and how you can kind of integrate them with the class-based system that exists in JavaScript. I should say Java. Let's talk about enums. Enums are another thing that I only recently discovered in my introduction to Java from JavaScript, and they kind of act like categories that you can draw on for referencing back to certain things, and they're a type of class, but they're not quite as, I suppose, constructed as classes. It's kind of hard to indicate exactly how they're used, because it's one of these things where when you see them in the code, it's really obvious why you'd use an enum there, and yet to give solid examples that would differ from just listing out a bunch of categories is, I suppose, difficult to indicate. But I suppose if you think about in JavaScript where you've got a set list of categories, and normally we would put these in an array, right? And we'd just refer to each of them as we needed them. But in Java, they've got this special kind of category, I suppose you say, or this special type called an enum, which allows us to create a set list of categories that we can then refer back to. And unlike in JavaScript, we can actually give these categories some properties that help us use them throughout our code. So for any sort of set list of categories that is not going to change in the scope of your program, that you want to refer back to or act as a central list that you will keep coming back to in some way, shape or form, you'd use an enum. So let's do it. You right click on your source folder, new Java class, enum, and we're going to do suits, card suits. All right, so let's have a look. And in its simplest form, this is all you need to do, right? Type hearts, diamonds, spades, and clubs. And that's an enum. This is, the convention is to put these in caps, and it's not particularly complex. I mean, you can see it's basically just saying these are the 4 suits that I want to work with for this program. And then it just acts exactly like how we would use an array of categories, right, in JavaScript. But it allows us to go into a bit more detail. So there are other things we can do. For example, we can give them display names. So we could do this. We can add some lines, and we can treat it a bit more like a class. So we can get into a bit more detail. So we can say, create a little constructor here. We'll say public suits. And then we'll say string, oops, capital S, string display name. And then we can do maybe the color, string color. Okay, and then we can do this dot display name equals display name, this dot color equals color. And of course, to assign these to attributes, just like with a class, we have to actually create these. So we would then say, I think in this case, private final string. And again, we're using this final keyword, right? Because they're not going to change, right? Diamonds isn't suddenly going to change to a black card, or it's not suddenly going to be written differently. So it's quite straightforward. And then we'll do private final string color. Right, and so now we can actually have it so that when this is like a constructor, and when someone actually calls this, they can indicate the display name and the color, right? That's how it would work if it were a standard class, but this isn't a standard class, this is an enum. And so you can see here, we've got these red underlines, and you can see here it's saying, oh, this constructor is not being applied, because what's actually happening here is that we're already declaring this an instance of this class, but we're calling it hearts. So what we actually need to do is put these attributes here, right? So then we do, yeah, see, and it's popped up again, IntelliJ being very helpful, and red, right? And then diamonds will be diamonds, and red also. Spades, we want to say spades, and black, and clubs. It's going right off the screen, you'll have to forgive me. But just trust me that I'm typing clubs and black. Not very well, but I'm doing it. Okay. And we can put these down, actually, to make this easier to see. Let's do it this way. There we go. So this is basically an enum, right? And it's showing us, okay, here are these 4 categories that we want to draw on. And then at some point, maybe we create another class of card, and we create 52 cards, and each one is assigned to have one of these suits. And then we can use the display name to connect to that card, etc., etc. So this kind of acts as like a source of truth for a set list of categories. It's one of those things that I feel comes easier to you once you've used it a few times. So hopefully this is a good introduction and allows us to move on to covering how to actually move through a lot of this stuff, in this case with loops and iterators, and then how to do some logic as well. And then we can wrap up. Okay, let's talk quickly about loops. Firstly, I'm not really going to go through do while loops or while do loops because they are almost identical. Almost identical to JavaScript. I mean, I can type one if you really want, but I mean, you literally type the same thing as you would in JavaScript, so don't sweat that one. Let's talk quickly about for loops. They are very, very similar to JavaScript. For, except rather than saying let I equal whatever, we say int I, right? Because we're working with a number, 0, and then we can say I is less than or equal to, we'll go back to our students.size example. Oh, it's not happy with us because we're not inside the main function. Here we go. Let's just pop ourselves back in there. There we go. Students.size, and then we'll just do I++. Yeah, and then we can go, oh, not I+, I++. Thank you. And then we could go log I don't know. Actually, not student in this case. Student number and then I or something, right? So that's a for loop. As I said, almost identical as you would see in JavaScript. One thing that is a bit different are the for each loops. They're very similar in terms of how they work, but they just look a bit different, right? So we can actually do this. We can say, what was our array called before? Names. Okay, great. So we can actually do for string name, and then this colon is kind of like the in, yeah, or of names. And then we can log the name, right? So this system out, as you probably guessed, is like console log, and fun trick in IntelliJ, if you type sout like this, then it will actually type all of that out for you so you don't have to type system.out.println every single time. It's a bit of a pain. So just press out and then enter. So those are loops. Pretty straightforward. The only thing is that there is a big difference with what are called iterators, and that's how to move through more complex collection types. So that's what we're going to talk about next, but as I said, quick and dirty version. But yeah, let's talk about iterators. Okay, so iterators are what we use when we need to move through an array list or a hash map. It can get really complex really quickly. So I'm just going to show you a quick example using an array list, and I'll leave it up to you for if and when you want to actually iterate through a hash map, because I mean, it's not usually how you work with hash maps anyway, right? But if you want to look that up, then go for it. But this will be like your little intro primer to iterators so that it makes sense later. So the main thing we want to do, we had our array list earlier. It was students. Great. Okay, so we have this array list called students. Yeah, array list is called students. Great, we know that now. And let's say we want to move through it. Well, what we have to do is we have to declare that we are going to use an iterator. So we're going to iterator, and if I'm not mistaken, it was string. Let's have a little look. Let's double check that. Yes, there were strings of names. That makes sense. Iterator string. And we're going to call it it. And then this is going to be students.iterator. And you can see, again, it's already popping up telling me that it needs to do this. And you can see it's red here. So what we actually need to do is we actually need to click this import class button. And then at the top, right at the very top of all, look at all this amazing stuff we've done. You can see that it's imported a few things. So actually Java will import some of the functionality that it needs. A lot of it doesn't come kind of in the box. So this is something that is, again, a bit different with JavaScript. And here it has kind of brought in the iterator that we are going to be using. You might be asking, why do we need an iterator? My friends, I don't really know, but all I know is that this is how Java works, so let's just learn it. So this iterator is, again, it's a class, I suppose, or a type, an object, and we're saying what is going to be inside each item that we're going to iterate through, and then we're calling on the native method that exists inside this array list in order to assign it to the variable it. Right, so basically our iterator is now called it, and what it does is it checks, or it looks at the items in the list and sees if there's something coming up next, and if there is, then it does something with it. So the classic use of this is this one. While it.hasNext, I'll just type it out first and then I'll explain it. Sout it, not next. Okay, so what's happening? So the first thing we're doing here is this while. It checks, is there another item, or in this case, is there an item to iterate through? Well, yes, there is, because we're just starting. And then we'll console log that item. And then it will check again. Oh, is there another item? Yes, there is. And it will keep going until it's finished iterating. So that's kind of one way to do it. That said, I mean, personally, I still find this a little bit confusing, but this is probably the easiest way to do it. You can iterate through hash maps. As I said, it does take a little more in the way of defining types and working with what are called entry sets. So I'll leave that up to you, but this is the basic way in which you use an iterator to loop through an array list. All right, so let's talk about conditionals. There's not much point in knowing all of this stuff if we can't put any logic behind it, and if else is, of course, our greatest friend in that regard. So they look identical in Java. There's a bird outside, and I bet you can hear it. Oh well. And here we go. We can have if 2 equals 2, right? Console log, it's 2, right? This will work. Now you might have noticed I only put 2 equal signs here. There is no other way. There is no triple equals here to work with. Because Java indicates the type inherently in so many parts of its program, you don't actually use triple equals. It doesn't really exist. So you can just use double equals for these kinds of things. But importantly, if we're comparing strings, if Bob Ross dot first name, right? And this is what I would do as a JavaScript programmer, equals Bob, right? And then we'll log, hi Bob. This bird, I tell you. Okay. And you can see here is a little something here. And if we hover over that, it says here string values are compared using double equals dot equals. Right, so if we click that, it shows us what Java prefers and uses. For comparing strings, we actually use the dot equals method. Now, what is kind of cool and is something else for you to look into as you get into Java is that much as with the ToString method, we can actually also override the equals method, and we can indicate how we want equals to work. So we might want to disregard case, for example. So this is something really cool to look into that I really like about Java, but I'm going to leave that for you guys to explore yourselves. Now we're almost done. We're on the last thing. We've kind of accidentally run into this thing anyway, so let's just delete that, and we're going to talk about console in and out. Now I've already mentioned that system out, yeah, sout, as I call it, sout. But the console in is a little bit trickier. The way that we do it, it's not really a process.argv, but they have a thing called a scanner. So what you can actually do, this is my preferred way. There are a few different ways you can take input from the user in Java, but this is my preferred way. You know, scanner input equals new scanner, and then system.in. Right? Okay. So what does this do? Well, again, this is actually imported something. If we scroll up. Up, here we go. It's imported this thing called a scanner, and that basically just takes input from the user. And then what we can do is we can say string, with a capital S, string username equals input dot next line, right? So we might say, please enter your name, right? Then it will give space for the user to enter the name. And when they press enter, that will be entered as their username. And it has to be a string. Everything they enter is automatically a string. So if we wanted to do this with age, well, let's just copy paste this first. Please enter your age. But we want their age stored as an integer, right? So we would say int user age equals. And now you can see here we've got a beautiful red line because, change variable user age type to string. Oh, well, we don't want it to be a string. We want it to be an integer. So what do? Well, luckily the scanner has this inbuilt method where you actually do next int, right? And then it will only read an integer that gets pulled in. Okay, so there are these cool inbuilt things with the scanner that help you pass data into the type that you need when you're pulling information in. So that's basically all there is to it. I mean, there's also next double, probably next car. I haven't checked, but I'm willing to bet. So anything like that you can probably work with here in order to pass it in advance. Alternatively, of course, you can what's called cast it by like changing the type like that, you know, but I would say since these methods exist within the scanner, use them, you know? So I think, thank you so much for bearing with me. I think that's everything you need to know to really get started in Java. And I hope that the comparison to JavaScript has helped you understand the basics of Java and will allow you to act as a launching off point where you can look into these things in more detail, practice by yourselves. I would definitely say the switch into object-oriented thinking is one of the hardest parts, and the second hardest part is just remembering to keep everything in the correct type and in line with those types as you program. But other than that, it is actually not as different as I thought it was going to be, and hopefully that's the impression that you've come away with as well. And with that in mind, thank you so much for listening. If you liked this video, I really would love you to comment, Like, comment, you can subscribe if you want to. I do plan to bring some more Java content in future. I'm also going to be looking more at React. And if you want more JavaScript content, I already have quite a few playlists with that stuff, especially for beginners. So if anything in here was unclear that I referred to in JavaScript, then I'm sure that you would be able to learn something from my videos as well. So thank you so much, and hopefully, yeah, you found this useful. Okay, have a wonderful journey with Java, and please do comment and let me know what you thought. Bye.